Dear students, in this video we are going to see 3.1 and 3.2. We know that if z is equal to x plus iy, then e to the power z is defined to be the complex number. E to the power z is equal to e power x cosine y plus I e power x sine y. This already we seen, and we know that what is Euler's formula, that is e power ix is equal to cosine x plus I sin x. Here we define the complex sine and cosine functions. Suppose z is a complex number, then what is cosine z? That is e to the power iz plus e to the power minus iz divided by 2. Then what is sine z is equal to e to the power iz minus e to the power minus iz over 2i. Similarly, for any complex number z, we define the hyperbolic function, that is sine h z is equal to e to the power z minus e to the power minus z over 2. Similarly, we can define cosine h z is equal to e to the power z plus e to the power minus z divided by 2. Here we do some questions how to change the given exponential form of the complex number into the a plus bi. Now we see the first question, that is exponential of 2 plus I pi over 4, that is nothing but e to the power 2 plus I pi over 4, that is e square multiply e to the power I pi over 4. Here base is e, so we can use this rule which you studied earlier, that is equal to e square multiply, here we apply the Euler's formula. See here e power ix is equal to cosine x plus I sin x, so that here we replace x by pi over 4, that is cosine pi over 4 plus I sin pi over 4, so that e square multiply cosine pi over 4 is nothing but 1 by root 2. So plus I 1 by root 2 for sine pi over 4 also. So that we will get e power 2 divided by square root of 2 plus I e power 2 divided by square root of 2. Okay, if we simplify, then finally we will get 4.4 plus 4.4 I. This is nothing but a plus bi form. Okay. Similarly, now we'll see the second question, that is cosine 1 minus I, cosine of the complex number 1 minus I. Now we know the rule for cosine z from the slide 2. So cosine z is equal to e to the power iz plus e to the power minus iz over 2. So that here we replace z by 1 minus I. So now e to the power I multiply 1 minus I plus e to the power minus I multiply 1 minus I over 2. So that e to the power you multiply I here, so we distribute I to 1 and minus I, so that I into 1 I into minus I squared will become plus 1 plus e to the power minus I, here minus I multiply plus I squared is minus 1, that's why you will get minus 1. Okay, so now divide by 2. After you distribute this I here and minus I here, you will get this and divide by 2. Now you separate this and then you find the value of e to the power 1 by using calculator, that is 2.7. Okay, now e to the power I, how you expand this? By Euler's rule. See, by Euler's formula you write cos 1 plus I sin 1, because here what is the value of x in this term? What is the value of x? Here value of x is 1. Okay, e to the power I, that is value of x is 1. So apply the Euler's formula here, and similarly e to the power minus I, apply this rule, so that you will get here for x is equal to minus 1, you will get cosine 1 minus I sin 1 by using this rule. Okay, then what you do, you use calculator in radian mode to find the value of cosine 1 sin 1. Okay, then you simplify it, you will get the final answer, but you have to write the final answer in this form, a plus bi form. Okay, don't forget. So here I leave for your calculation. Okay, you use calculator, then find the value, you write here finally. So finally you write the answer in the form of a plus bi. That's it. Now you see question number 3, sine h of 1 plus pi I. Here we know the rule for the hyperbolic of sine, so that is sine h z is e power z minus e power minus z over 2. So that here you take z as 1 plus pi I and replace here. So that e to the power 1 plus pi I plus e to the power minus of 1 plus pi I divided by 2 by using this rule. Okay. Now e to the power 1, say here e to the power 1 plus pi I, here base is e, so that we can write like this. Then you apply the Euler's formula here, e to the power pi I, and apply the formula here, e to the power minus pi I. So here x is pi, here x is minus pi. Okay, so that 2.7 e to the power 1 is 2.7. Then apply the value cosine pi plus I sin pi. Then here for this one cosine pi minus I sin pi. See, use these two results. Okay, so that now you can write the value of cos pi by using the calculator in radian mode. Okay, this is minus 1, sin pi is 0. Similarly here this is minus 1, sin pi is 0. Then you multiply 2.7 and here you multiply 0.4. Then you simplify it, you will get the final answer like this. This is nothing but a plus bi form. A is minus 1.55 and then here b is 0. Okay, this is the complex number form. Okay, now you'll see two rules here. What is the first one? The equation a to the power z is equal to 1 if and only if z is equal to 2k pi I, where k is an integer. Similarly, another result is the equation e to the power z1 is equal to e to the power z2 if and only if z1 is equal to z2 plus 2k pi I. Here also k is an integer. Okay, now see here, find all numbers z in the given question. Now we have to find the value of z. Now you see here what is given, e to the power 4z is equal to 1 is given. Okay, now the above two rules which is suitable here to apply in question number 1. We can select rule number 1, that is e to the power z is equal to 1 if and only if z equal to 2k pi I. So that now here you compare. See, e to the power 4z is equal to 1. So now here z given in the rule, here 4z in the question. So now we can write 4z is equal to 2k. Here z equal to 2k pi I. So that here 4z equal to 2k pi I. Okay. So that now we write z is equal to, see, k pi I over 2. Why? Because you cross multiply 4 here, so it will come in the denominator, so that you cancel 2 and 2, so that k pi I over 2, that is the value of z, where what is k? K is an integer, that is nothing but 0 plus or minus 1 plus or minus 2 etc. Okay, this is by rule 1, you can write by rule 1. Okay, now you see here question number 2, e to the power I z is equal to 3, e to the power I z equal to 3. Okay, so now here which rule I am going to use? I am going to use, because I am going to use rule number 2. Why? Because here e to the power I z is equal to 1. Suppose it is given 1, then I can use rule number 1. But here e to the power z1 equal to e to the power z2 if and only if z1 is equal to z2 plus 2k pi I, where k is an integer. Okay, I select rule number 2. Okay, because here 1 is not given in the question. Okay, so that e to the power I z, to apply rule number 2, I modify little bit this right side, so that e power I z is equal to e to the power ln 3. Okay, now here if you apply rule number 2, see, apply rule number 2, here this is z1 I z left side, this is z2, okay, ln 3 plus 2k pi I by rule number 2. but what we need z. Okay, we have to find all values of z, so that z is equal to ln, you divide by I. Okay, you divide by I this equation. So now here z will come, here ln over I, here 2k pi a over I. So here I and I cancel, so that 2k pi, here ln over 3. Okay, so here what you have to do, as we studied in week 1, if any complex number appears in the denominator, you must take the conjugate of the complex number, then multiply in the numerator and denominator, then simplify it. Okay, so what you do here, listen, complex conjugate of I, you take complex conjugate of I, that is minus I, so that you multiply here minus I in the numerator and in the denominator. So if you multiply in the denominator minus I with this, I into minus I is minus I square. Minus I square is nothing but plus 1, so that here in the denominator plus 1 will come. Then here I multiplied minus I in the numerator also, that's why here we get minus I ln 3 plus 2k pi. Okay, here I and I cancel, so this is the value of z. This is all values of z when you replace k by any integer. Means if you put k is equal to 0, k equal to plus 1, k equal to minus 1 something, so you will get different z values. Okay, so this is the final answer for z, where what is k? K is an integer. Now we will see the continuation of this in the next video.